Alright, so this kind of is an add-on lesson. A lot of this lesson is kind of a re-review of the previous set of notes, but there's some additional stuff added on to it. So I wanted to get you familiar with some of the words like a chord, a secant line, and a tangent, which we're going to review those again, and then there's going to be some stuff in addition. So first, kind of review some of the stuff. What is a tangent line? Remember, if you are told you have a tangent line, that means that the line is touching the circle on its edge at one point. So it's a line that touches a circle. It's a circle at only one point. Okay, that's what a secant line is. For instance, in this circle here at the right, this line right here that I'm highlighting in red, that is a tangent line because at point A it touches the circle at one point. Okay, and that would be called the point of tangency. So we'll go ahead and add that point A here in this circle is the point of tangency. Okay, the next type of line that we talked about with circles was a secant line. Remember what a secant line does. A secant line is a line. Remember what a line is. A line has at least 2 points on it, and it continues to go in each direction without end. So it's a line that touches a circle, and I'm just going to use this symbol for circle. Okay, at 2 points. I forgot to write my 2. I'll use a black at 2 points. For instance, we'll use blue here. This line here that has E and B, that is a secant line because it has 2 points on the circle here, point E and point B, and then it has a line because, how do I know it's a line? Because of the arrows at each end. And so line EB is the secant line. And so here it said give you an example. Well, we just talked about it, that an example would be the line EB. Okay. Then we also talked about radius and a diameter. Remember what a radius is. A radius is half the width. So when you look at this circle over here at the right that has S as its center, isn't there 2 radiuses? There's the radius SD, and also, isn't there also the radius SC? And what can we say is true about those 2 radiuses, SD and SC? They're equal, because the radius of a circle, any radius of a circle is congruent to any other radius of the same circle. Okay. Then we talked about diameter. Remember what diameter is? Diameter is the whole width. Okay. So D to C. Now, to be a diameter, you must be touching 2 points on a circle. So notice how C and D, as I circle them and highlight them in red, are on the circle. But the key thing is that it goes through the center. Okay, it goes through the center. Okay, and it's the whole width. And then the last thing was a chord. A chord is a segment, not a line. That means it has a starting point and an ending point. But it's just, to be a chord, you just have to be 2 points on the line. And actually, there are 2 chords here. You have EB, and when I say EB, I'm talking about starting at E and only going to B and not extending out any further than that. I'm just talking about this distance in red that I've highlighted. I'm not going outside the circle. I'm starting at E and ending at B and not going any further. So a secant line and a chord are similar. The difference is that if it's a chord, it has a starting point and end point, and it doesn't go outside those points. Also, you have one other chord here, your diameter. Isn't DC the diameter? Isn't that also a segment? It has 2 endpoints on the circle. It's not only a chord, DC, but it's also the diameter. What makes it be the diameter? Because it goes through the center. So kind of a quick review of the last lesson. Okay, so let's see how you guys can do on this little section, because this is a review, so really I want you guys to answer these questions here 1 through 6 yourself using this diagram at the right. Okay, this diagram here that I'm drawing the red circle. Okay, and answer the questions. For instance, number 1, they want to know two radiuses or two radii. Name a chord, so you just have to name one. Name a diameter, and so on. When you're finished with naming answering those 6 questions, raise your hand and ask, to check your work, you can raise your hand and ask the sub, and they can tell you if you got it right or not. If you get stuck, ask for help. All right, so the bottom of this page is still some review stuff. Okay, this is from the other day. Okay, remember that we had learned 2 theorems. The first one was the tangent line to a circle theorem. And what it said is if line M is tangent to circle Q, then it's going to be perpendicular to the radius. So QP here, that is a radius. And since this line is a tangent line and QP is a radius, well, when they touch each other at P, it's making a right angle. So down here in the bottom, that means that angle QPS, or you could put QPM, is 90 degrees, because if it's perpendicular, the perpendicular lines make a right angle. These 2 examples were just like the notes that we did the other day. They're the same exact problems, but we're going to go ahead and do it just for more practice. It says if ST is tangent to circle P, in other words, this line right here, if ST, this line, is tangent to the circle, okay, then they want us to find something. So what we're going to determine, or they're asking, is it tangent? Well, for it to be tangent, isn't PT the radius of the circle? Right? It is a radius. Well, if for ST to be a tangent line, then it has to be making a right angle right here, where it touches the radius. Well, so we have 3 measures of this triangle that we have. Well, if those 3 measures make a right triangle, then that means it's perpendicular and it would be a tangent line. Well, how can we prove if these 3 measures, 35, 12, and 37, make a right triangle? The Pythagorean theorem. So 35 and 12 are my legs, so I would go 12 squared plus 35 squared equals 37 squared. Okay. And then I would do my math to see 144, or 12 squared is 144. 35 squared, I don't have my calculator real quick. I know 37 squared is 1,369. And anyway, when you do these totals here, whenever you do 35 times 35 squared, what you end up getting, I don't have my calculator with me, but you end up getting that those 2 things do, the 2 legs squared and added equals the hypotenuse squared, so therefore it is a right triangle, which means this is a tangent line. So that's one way you could prove it. In number 8, it's a little different. It says in the diagram, point B is a point of tangency. So since you know it's a point of tangency, then that means when B, the point of tangency, touches the radius right here, BC is the radius, when it touches the radius right there, we know it makes a right triangle. Well, they want us to find out what the radius is. Well, let's write what we know. Use the Pythagorean theorem. This 80 feet, isn't that one of the legs? And this missing R right here, that side, that's the other leg. So wouldn't I have 80 squared plus R squared equals the hypotenuse squared, which the hypotenuse is from here to the edge of the circle, and then that radius. Well, if I knew what R was, wouldn't I add it to 50, and that'd be my hypotenuse? So I have 50 plus R squared. Okay, and so I do my math. 80 squared is 6,400, or 6,400. That's still R squared. And 50 plus R squared gives me 2,500 plus 100R, ran out of room, plus r squared. Well, if you remember when we did this in the notes the other day, the first thing you do is you could subtract this r squared from both sides, and when you subtract r squared, that's going to cancel out, and that's going to cancel out, and so now I'm left with 6,400 equals 2,500 plus 100r. Okay, and so now I need to, if you look over here, I have 2,500 plus 100r. Well, let's get rid of this 2,500. So we would subtract 2,500 from both sides, and when we do, what we get is we get 3,900 equals 100r. How can you get r by itself? Divide it, right? And so you get the r equals 39, and so the radius is 39. Okay, so that was a review problem from the previous set of. All right, the second page. We also did this, so this is a review as well. Okay, but it was the second theorem that they gave you, and it was the external tangent congruence theorem. What this means is if you have two tangent lines, external means outside. When they tell you external, it means it's outside or it's on the edge of the circle. Okay. But what you have is you have two tangent lines. Look at this diagram. You have RS is a tangent line and RT is a tangent line. But look, both the tangent lines share the same outside external point. Well, if that happens in a circle where two tangent lines share the same external point, then the tangent lines are congruent. In other words, in the theorem right here, RS is congruent to RT. Well, we have the same thing going on over here. That means RS is congruent to RT. So therefore, since RS is equal or congruent to RT, then doesn't that mean that 28 has to be equal to that? So 28 equals 3x plus 4. I'm going to subtract 4. So now I have 24 equals, not very good, 24 equals 3x. I'll divide by 3, and you find that x equals 8. Right? You guys remember that problem from the notes? Okay, so now we're going to start getting into some new material that wasn't there, and it's talking about finding arc measures. What arc measures are? They are pieces of the circumference. Remember what circumference is. Circumference is the distance around the circle. You know, you can't find the perimeter of a circle, but the circumference, for instance, if I start right here and measure around the circle, that's the circumference. Well, that's what an arc is. It's a piece of it, okay? So the measure of a circle all the way around, if I went around one time around any circle, I would get a total of 360 degrees. So the complete rotation or complete arc of a whole circle is 360 degrees. Well, what would be the measure of a semicircle? And it'd be half that, right? So it'd be 180 degrees. Okay. All right, well, kind of a new term here, and that's the word central angle. Okay, and then right here they say angle ACB is a central angle because. Well, this is what they're talking about. They're talking about this angle right here, point ACB. They're talking about that angle that is formed right here. That is a central angle. Why is that a central angle? Well, isn't C, point C, isn't that the center of the circle? Yeah. So that angle that's being formed there is a central angle. And so this angle is, since I said it's 50, that angle would be 50 degrees. Well, then they talk about a minor arc. Okay? A arc is a minor arc anytime it is less than 180 degrees. And notice this symbol right above AB. See that little curved symbol on top of AB? That you read that as arc AB. And anytime you name an arc with 2 points, you are naming a minor arc. You could be naming a semicircle, but you're usually doing a minor arc, and a minor arc is something that is less than 180. Well, let's go back over here to this diagram. Remember we talked about the central angle here. This angle that's being formed from the center of the circle, which is C, and that angle there, which is 50 degrees. Well, let me change colors. You see this piece right here between A and B? That piece of the circumference of the circle? Okay, that's arc AB, and it's congruent and equal to its central angle. So since the central angle is 50, the measure of arc AB is 50 degrees. It's 50 degrees of the whole 360. Okay, then we have another type of arc, and that's called a major arc. Well, a major arc is anything that is greater than 180. So let's think about it. We've just talked about, you have several different arcs. Here's your first one. You have a semicircle. Well, for it to be a semicircle, it has to be 180 degrees. It has to be half the measure. Doesn't that mean you have to be using the diameter, right? Then you have a minor arc, which is less than 180 degrees. And then you have a major arc, which is greater than 180. And notice here on the major arc, and I'll use red, they used that symbol to talk about an arc, but they used 3 points. And so I'm going to use red right here. But notice what they do. A through D to B. So they're talking about that part right there that I've done in red. Going around the circle. See how I keep making that red line thicker and thicker and thicker. But I'm not going all the way around. I'm starting at A and then stopping at B. Well, what would that measure be? What would arc ADB be? Now, let's think about this. The entire circle all the way around is 360 degrees, right? That's the entire arc of a whole circle. And this minor arc, remember this minor arc right here, arc AB, this piece right here that I'm going to highlight in black, that's 50 degrees of the 360. Well, what's left? Well, 360 minus 50. 360 minus 50 would be 310. And so the major arc, ADB, is 310 degrees. Well, let's do some more of this again. So let's look at the practice here, 10 through 17. I'm going to do some of them, and then I'm going to give you some to do. But they want you to do two things. They want you to identify or name the arcs. Is it a major arc? Is it a minor arc? Or is it a semicircle? Well, remember, for it to be a semicircle, it has to equal exactly 180. For it to be a minor arc, it has to be smaller or less than 180. And for it to be a major arc, it has to be greater. Running out of room. But it has to be greater than 180. So let's start with number 10, AB. So they're wanting you to find that one right there. That's the arc AB. So before we go any further, isn't AC, isn't that the diameter? Right? So isn't this arc right here starting at A and going to B? First of all, it's using 2 points, so we know it can't be a major arc, right? And it's not a semicircle, because to be a semicircle, it'd have to go all the way to C. It's not doing that. So it's a minor arc. Number 10 is a minor arc. And so now we need to figure out, well, what is this degree measure? Well, they do give you a little piece of information here. They tell you that AC is perpendicular to BE. Well, what does that mean? Here's AC, this red line going across the diameter, and it's perpendicular to EB, this radius right here. Well, what happens when we know something is perpendicular? We have a right angle. So aren't they telling you that I have 2 right angles right there? Well, isn't the central angle right here 90 degrees? Yes. So if the central angle is 90 degrees, what is the arc AB? It's 90 degrees. Okay. So let's go on and we'll do number 11 together. We're going to do arc ABC. So you go in the order that they label it. So starting at A, going to B, and stopping at C. So we're going right there. Well, didn't I end up starting at A and I ended at C? And isn't AC the diameter? So wouldn't the diameter cut a circle exactly in half? So isn't this a semicircle arc? So this is a semicircle. I'm just going to write semi because I can't write that small on this iPad. And every semicircle is always 180 degrees. Okay. So let's do number 12. Arc ABD. Again, we go in the order of the points given. A, B, we pass C, and we're going to stop at D. Well, let's think about this. We already did from A to C. That was the previous problem, was 180. Well, now we're going a little bit further to D. Well, didn't we add this central angle here? The central angle is 40. Doesn't that mean the arc DC is 40? So don't we have 180 plus 40? Okay. So it's not a minor. It's not a minor arc, and it's not a semicircle. So it's a major. And what does it equal? Well, 180 plus 40 is 220. Okay. All right. So I'm going to stop right there. I want you guys to do number 13, 14, 15, 16, and 17 on your own. Name what type of arc it is, and then tell me what the measure of the arc is. When you have these completed, raise your hand and have the sub come by and see if you got it right. And then if you get stuck on anything, ask for help or ask somebody next to you. And then when you're finished this, then you may go ahead and finish the notes. All right. So number 18. Number 18 still goes with the same set of problems that we were doing here, the same circle. So let's see what they ask us. They want us to tell in circle E if arc ABC is congruent to arc ADC. Explain why or why not. So ABC, well, we've already done ABC. ABC, I'm going to change to a marker. ABC, that's ABC. Well, isn't that a semicircle, right? And so now, get a little smaller marker. Okay, arc ADC, ADC. Well, isn't that the semicircle on the other side? So they're both semicircles, so aren't they both 180? And so, yes. Oops, I forgot to switch back to my pen. Yes. And there's several things you say, but really the main thing, the easiest thing to say is because AC, notice how AC is two of the points in both of those arcs, because AC is the diameter. It's going to cut the circle in half into two equal parts, right? All right, so let's do number 19 together. Okay. So they want us to find the value of x, and then they want us to find the measure of AB. So there's two things here. They want us to find x, and then they want us to find the measure of AB. All right. So we can look at this thing here. If you notice, there's a value here that has an x in it, and there's a value here that has an x in it, and then we know everything else. Okay. All right. Well, there's several things you can do here, but first is let's find x. Well, when I look at all these things, I'm going to use red. If I took this arc here, going from A, B, and then I did this arc here, BC. Okay, do that in blue. And then I did this arc here, CD. And then do a different color. Okay. And then this arc here. Okay. aren't all those different colors of arcs that I just did, wouldn't that be the complete circle all the way around, all the arcs together? And what do all the arcs all the way around the circle one time equal? That's right, 360 degrees. So that means that that first arc, 5x, plus the next arc, which is 40, plus the next arc, which is 70, plus the last arc, which is 75 plus 2x, all those have to add up and equal 360, right? Well, now, combine your like terms. That will add to that and to that, because those are just numbers, right? And 5x and 2x, those are like terms, so add them together. So how many x's do I have? That's right, I have 7x. And now I'm going to add my numbers to see 70 and 75 is 145. Okay, and then I'm going to add 40 to that. So 145 and 40 would be 185. Okay, so now it's just a two-step equation. Okay. Subtract 185. I'm going to kind of go over here to the side a little bit. Okay. And 360 minus 185 would give me, I'd have 7x equals 175. And then I would divide by 7. And what you find is that x equals what? 25. So you just found the first part of the problem. That was the first part of the problem, is they wanted you to find what x is. So we've done that. So on the last thing that they want you to do is they wanted you to find what AB equals. Well, where is AB? Remember, AB is this thick red arc that I'm doing right here. Well, isn't it that 5x? We just found what x is, so how can I find what AB is? That's right, I'm going to go 5x, and for x I'm going to put in 25, and so what is 5 times 25? It's 125. So arc AB equals 125 degrees. And you don't have to write this down, but let's think about this. Arc AB is 125 degrees. So, what type of arc is AB? What type of arc is this one right here that has the thick red marking that I just put in black? It's 125 degrees. Well, one more question. Isn't this angle here, where I got the blue arc inside, isn't that angle the central angle to that arc? Well, if that arc equals 125, what is this angle, central angle, equal? 125. So don't forget about your central angles, and your arcs have the same measure. All right. The last page of notes. And now we're getting to where there's some more stuff. Again, some of this was review, and some of this is add-on. So let's talk about these three theorems. Okay. The first one is the congruent corresponding chords theorem. It says in the same circle, or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So I'm going to highlight the two chords in blue. Here's AB and there's CD. Those two things there are chords. Those are chords. Remember, 2 points on a circle, right? And they're telling you they're congruent. Well, since they are congruent, okay, then that means that their arcs, arc AB and arc CD, are congruent. In other words, if I told you that CD, if arc CD, if I told you it equaled 100 degrees, then what would arc AB equal? It would also equal 100 degrees. Why? Because the chords are congruent. Okay, let me ask you this question. What if they told you the chords were or the arcs were congruent? What would we know about the corresponding chords? They would also be congruent. They're conditional on each other. How do I know that? This statement right here, hang on there. Let me get a good color to highlight that. This statement right there, if and only if Remember that when we did conditional statements, if and only if means they're conditional. Both of them are conditional on each other. If you have one, you have the other. It doesn't matter which one's first. Okay? All right. So go ahead and go on to the second theorem. It's the perpendicular chord bisector theorem. It says, if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord in this arc. So here, I'm going to use red for the diameter. So there's our diameter. I'm going to put EG, and I'm just going to put a big D for diameter. Okay, so that's our diameter. Well, then this other part, FD, that's a D right there, that's our chord. Well, if EG bisects a chord, or intersects it, or not, if it's perpendicular when it intersects, and that's what they tell you right here, then it's bisecting it. So what is that going to do? Let's think about what that's going to do if it's bisected. Well, first of all, doesn't that mean that this piece and this piece are congruent? Isn't this point right here in black that I'm making, wouldn't that be a midpoint right there on the chord? And also, FG, that arc, and DG, they're going to be congruent arcs. Okay. Alright, now our last one, the equidistant. Remember, equidistant just means equal distance. Equidistance means equal distance or congruent distance. But the equidistant chords theorem, it says in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So I'm going to use blue for the chords, AB, or black for the chords. AB is one chord, CD is the other chord. And what they're saying is that the chords are equidistant. See the little red that I'm making? They're equidistant from the center, from E. Okay? And so that means they're also going to be congruent to each other. So a few little new tricks. So let's do some of this that we've just done together. Alright? Dealing with the chords. The first one, find the measure of the arc or chord in circle Q. So the first thing they want us to do is they want us to find WX. Well, WX is this piece right there going across. And it is a chord. Because what? At one point, there's 2 points on the circle. Well, isn't this measure right there? They've given it to me right there. So it's 3.6. Then they want me to find YZ. Okay. Well, YZ is this chord down here. Well, since this chord, these chords are connected to the other, isn't this going to be congruent to that? So it's 3.6. YZ and WX are equidistant from each other. Okay. WZ, they want me to find WZ. Well, WZ is this chord. What chord is congruent to WZ? That's right. This one right here, XY. Well, if XY equals 9.2, because they gave it to me, then that means WZ is also 9.2. And then they have this last thing, which is XY. Well, XY is this chord here, which they've already given it to me. So that's 9.2. Oh, excuse me. They're not wanting the measure. Oops, I need to use my eraser real quick. Because when they put measure, I'll show what I did, what I messed up. They're not asking, since they put the little M in front of both of these, they're wanting the arc measure. Sorry about that. So, the only thing I have as far as a degree measure is this 42 degrees. Well, isn't that this central angle right here that I'm shading in right here? Well, doesn't this arc correspond with that angle? So isn't ZY 42 degrees, that arc? Okay, now 420, 42 degrees. Well, isn't this arc here, XY, aren't those corresponding arcs? Yes, they are. So WX is also 42 degrees. Okay, and then they want me to find the arc AC, or excuse me, XY, I'm sorry. Well, it would be corresponding to this arc over here, but we don't know anything about it. But we do. Think about this. I'm going to use red. We know that this arc, I'm going to go to a marker. This arc here and this arc here, they're both 42. Those two red pieces are 42 each. And then everything else, isn't everything else this arc here and this arc here? Well, let's add the two measures that we know. Right now we know we have 42 and 42, so we know we have 84 degrees being used with the two little arcs, right? I'm going to go ahead and circle them in blue. And then we also know that in a circle, the total is 360. Well, subtract that from the 84, and what you get let's see, I don't have my calculator, so 360 minus 84. Let's see, borrow, see, 10 minus 4 is 6, 15 is 7, and I still have 2. So I have 276 degrees, but it's divided up equally. This 276, that's a 6 right there. That 276 doesn't have to be divided up equally between this arc and that arc. So how can I figure out what that is? Divide it by 2, right? 276 divided by 2. And so you would get 138. So x, y, this arc over here is 138, and this arc over here is also 138. All right. Number 20 says find the value of x. Well, I'm going to give you a hint. You guys are going to do number 24, but I'm going to give you a hint. Okay. This has to do with SQ is my diameter. This object here in red, that is my diameter. And this blue marker, that is my chord. And the next piece of information that you have is that they tell you that you have a right angle being formed right here when the diameter intersects the chord. Well, something happens right there. What happens? And you can look at the theorem at the top. Anytime a diameter intersects a chord and is perpendicular, then it's bisecting the chord, meaning this point right here, that is T, where they intersect, that is a midpoint. So if they're midpoint, doesn't that mean that this piece is equal to that piece, right? There's your hint. And then I'm also going to give you a hint for number 25 as well. They want you to find the radius. Okay. They want you to find the radius. No, I don't want you to do number 25. Leave number 25 alone. So do number 24. If you once you think you have the answer to number 24, go ahead and raise your hand and have the substitute come by and check your work. Once you're finished with this, go ahead and begin the assignment. And these notes and the assignment that goes with it, they're not stapled together, but you should have grabbed that when you came in and grabbed this packet. But these notes and this assignment are due your next class period. The notes and the assignment, they need to get turned in either to the substitute or me, or be put in my mailbox. Okay? Alright.